Okay, so let A1, A2, A3 all the way till A101 are in GP, with A101 is 25 and summation from I equals to 1 to 201 of AI is 625. Then the value of the summation from I, so it's J equals to 1, I think. From J equals to 1 to 201 of 1 upon A, and it's the same thing. Whatever, it doesn't matter. So what we are given is that the last term is 25. We are also given the sum of this GP till 201 terms, and we want to find the sum of the reciprocals of this GP. So not a bad question. Let's just try it out. So first of all, you have that A101 is 25. Okay, fine. So that tells me that A times, here A means A1, so A times R power 100, that is 25. And we also have the summation from I equals to 1 to 201 of AI, which is A times R power 201 minus 1 upon R minus 1. Yes, that's correct. That is 625. Okay, then the value of the summation from I equals to 1 to 201 of 1 upon AI. So for 1 upon AI, the first term will be 1 upon A, and the ratio will be 1 upon R. So 1 upon R power 201 minus 1 upon 1 upon R minus 1. What is that supposed to be? Okay, so that's supposed to be equal to, well, let's see, 1 upon A into R power 201 minus 1 upon R minus 1, but into something else. So it's supposed to be 1 upon R and then 201 over there, and this is like 1 upon R. Right, right. So 1 upon R, so that's, it's like R going to go up, so this will be like 1 upon R power 200, something like that. Okay, fine. So what I can write it like is A into R power 201 minus 1 upon R minus 1 into 1 upon A R power 100 squared. So that's supposed to be, well, we know what this thing is. This thing is just 625, and we also know what this thing is. This thing is just 25. So just 25 upon 25, that's just 25 itself. Okay, cool. So that's the value of this sum. This is supposed to be equal to 25. Okay, so let's move on. If the roots of 10x cubed minus nx squared minus 54x minus 27 equals to 0 are in a harmonic progression, then n equals. Okay, so because they are in a harmonic progression, their reciprocals will be like an arithmetic progression. Okay, fine. What can we do? Okay, wait a second. Sorry for the disturbance. Fine. So we are given that the roots are in harmonic progression of this equation. We know that alpha, beta, gamma over here, that will be 27 upon 10. And we also know that alpha, beta plus beta, gamma plus gamma alpha, that will be, I think, negative 54 upon 10. Okay, so if I divide this equation by that equation, I will get 1 upon alpha plus 1 upon beta plus 1 upon gamma. That will be what, this thing upon that thing, this is supposed to be negative 2. Okay, not bad. But now we can use the fact that because alpha, beta, gamma are in harmonic progression, the reciprocals will be in arithmetic progression. So this thing is actually the same thing as 3 upon beta, because 1 upon alpha plus 1 upon gamma is the same thing as 2 upon beta. Okay, so that will give me beta is equal to negative 3 by 2. In other words, negative 3 by 2 is a root of this equation. So if I put negative 3 by 2 into that thing, I will get 0. So that means we can actually find value of n very easily. Right, so we just want to put negative 3 by 2 into that equation and get the value of n. So that will be like 10 into negative 3 by 2 cubed. So this will be like negative 27 upon 8, then minus nx squared, which is like minus 9n upon 4, then minus 54 into negative 3 by 2, so that will be plus 54 into 3 by 2, which will be like 27 into 3, which is 81, and then finally minus 27 into 3 by 2, no, nothing, so like that's a constant value. So supposed to be equal to 0. Okay, so what can we do? We can factor out a 9 from that thing. So 10 into minus 3 by 8 minus n upon 4 plus 9 minus, what do you have, 9 minus 3, right, so 9 minus 3 is equal to 0. So that's like saying maybe we can multiply by 8 as well. Actually this can be written as 5 upon 4, so we need to multiply by 4 in that case. Right, so you have negative 15 upon 4, negative n upon 4 is okay, so plus 6 is equal to 0, so that will give me 24 is equals to 15 plus n, which means n is equal to 9. Looks correct. So there are 9 terms in this sequence, right? Let's move on. There could be that I made some mistake, but never mind that. At least you know the method now. Fine, so let's move on. The terms a1, a2, a3 form an arithmetic, wait a second, form an arithmetic sequence whose sum is 18. The terms a1 plus 1, a2, a3 plus 2 in that order form a geometric sequence, and the absolute value of the sum of all possible common difference of the AP is. Okay, cool. So because the sum of that arithmetic sequence is 18, we know that a2 is going to be 18 upon 3, which is 6. So you got these things, 6 plus t and 6 minus t. These are the values of a1, a2 and a3 respectively, right? And we are given this thing that a1 plus 1, a2, a3 plus 2. Wait, a2, oh, so it's supposed to be a comma over there. Okay, so maybe like a1 plus 1, a2 and a3 plus 2 in that order form a geometric sequence, right? So you will have a2 squared is equal to a3 plus 2 into a1 plus 1. Fine, but what is this a2 thing? It's just 36 over there. So like 36 equals to a3 is 6 plus t, so 6 plus t plus 2, that will be 8 plus t, and then a1 plus 1, that will be 6 minus t plus 1, which is 7 minus t, right? So that's this equation. We can write it like this: t minus 7 into t plus 8 plus 36 is equal to 0. So that will give me like d squared uh, plus d, and then you got 36 minus 56, which is minus 20, is equal to 0. So we can write it like this: t plus 5 into d minus 4 has to be equal to 0. Okay, so any other condition which we are given, form a geometric sequence, then the absolute value of the sum of all possible common differences of the APs, right? So the terms a1, a2, a3 form a arithmetic sequence of sum is 18, right? That is taken care of. The terms a1, a2 and a3 plus a1 plus 1, a2 and a3 plus 2 in that order form a geometric sequence. It's not even that the geometric sequence needs to be increasing, decreasing or anything. Neither is anything even for the arithmetic sequence. So d is free to be any of these values. So like d can be minus 5 or d can be 4. Both conditions will be good. So if d equals to 5, then that will give me that our a2 is 6, obviously. Our a3 will be, I think, 1, and then this thing will turn out to be what, 6 plus 5, 11, right? So if we modify this, if we put a1 plus 1, a2 and a3 plus 2, we will get 12, 6 and 3. So over here the ratio is I think 1 upon 2. So our ratio will be 1 upon 2 over here. When d equals to 4, we will get 6 over there, and then 10 and 2. Okay, so if I modify that thing, right, if we add 1 to that, and we will get 3, and then this remains the same, and 10 plus 2, right, so 12. So over here the ratio is 2. Sum of, okay, absolute value of a sum of all possible common difference of the APs. Oh, so we, okay, so we didn't actually have to find the common ratio, it was the common difference itself. Okay, fine. So yes, the absolute value of their sum, that will be 1. So 1, right, easy. Let's move on. the difference between the sum of the first k terms of the series 1 cube plus 2 cube plus 3 cube plus all the way till n cubed, and the sum of the first k terms of this thing 1 plus 2 plus 3 all the way till n is 1980. Then the value of k is okay. So this series can be written as n into n plus 1 upon 4 sorry upon 2 squared, and then this thing is just n into n plus 1 upon 2. This difference is 1980. This is almost the same thing as saying x squared minus x is equals to 1980, where x is this thing, right? This thing is x. Okay, fine. So you got x squared minus x minus 1980 is supposed to be equal to 0. So we just need to find some solution to that. Okay, how do I factor this thing? So first of all, 1 is like an odd number, so maybe we can take all the 2's of this thing on one side, and then everything else will be on the other side. Fine. So 1980, how do I factorize this thing? So this is like 8, okay, so 2 into, okay, 2 into, you got 18, which is 9, and then 18 once again is 990. Okay, all right. So 1980, maybe that's not where we should be going. It's like 98. All right, so let's just take 2 power 2 over there. It's like, okay, so 8 4 and then 19, you need 9 once again, and then you have 10. So this thing, so 2 power 2 into 5 into what is this thing, 45, we need 9, and then 45 once again, so we need 9. So 2 power 2 into 5 into 9 into 11. Okay, what do I do with this thing? This is not what I was expecting. Okay, so that thing is indeed 1980. The difference between the sum is 1980, then the value of k is, wow, it's quite a problem. Okay, what can we do? So we want to factor this into something which will actually have a difference of 1. So 2 squared into 5 into 9 into 11. So 2 squared into 5, that's 20. 9 into 11 is 99. Not gonna work. 45 into 4. Oh yes, that actually was nice. So 45 into 44, right? So that was an easy solution. It's like x squared minus 45x plus 44 x minus 1980 is equal to 0. So that will give me x minus 45 into x, I think x plus 44 is equal to 0, but obviously x needs to be positive over there, so this cannot be equal to 0, so that's not in the case. So like x has to be 45 in that case. So n into n plus 1 upon 2, that is 45. So n into n plus 1 is 90, and 90 is just like 9 into 10. So this is very clear that n has to be 9 for this to be happening. If you go any higher, you will not get this value, you will get something bigger. If you go lower, you will get something just smaller than this value. So n equals to 9 is the only solution, right? So n equals to 9. Then the value of k is, wait, what? Oh, so the difference between the sum of the first k terms of the series and the sum of the first, oh, it's the same thing, right? So first n terms, first k terms, pretty much the same thing. So the value of k is the same value as for n, so it will be like 9. Okay, let's move on. So sum of positive integral ordered pairs a and b such that 6a and b are in harmonic progression is, so you got 1 upon a, actually 2 upon a is equals to 1 upon b plus 1 upon 6. So let's multiply this by 6ab, that will give me 12b is equal to 6ab, so 6 into a plus ab, right, looks correct to me. Okay, so that gives me ab plus 6a minus 12b is equal to 0, and this is like a very famous category of equation. This is called a linear Diophantine. Okay, in this case it's not exactly linear, but it's factorizable, so not bad, we can actually solve this. A linear Diophantine equation is of the form ax plus by is equal to some constancy where all of these are like integers and stuff. It's not like that, but it is of very well-known form, and we can actually factorize this thing uh, by doing some tricks like b plus 6 and then minus 12, and I want b plus 6 over there, so I will put an additional 6, but then now I need to subtract that 6 as well. So minus 6 into minus 12, that will be 72. So positive 72 is equal to 0. Cool. Oops. So you will get a minus 12 into b plus 6 is equal to negative 72. In other words, 72 is equals to 12 minus a into b plus 6. Alright, and what are we given? Where was I? Oh, so number of positive integral ordered pairs. So because a and b are positive, we clearly see that this number is going to be bigger than or equal to 7. So if I talk about the factors of this guy, this can be, what is this first of all? It's just 8 into 9, which is 2 cubed into 3 squared. So that's going to be like 4 into 3, which is 12 factors of this guy. But we don't need to look at all of those 12 factors. In fact, we need to look only for those which are bigger than 7. So let's start. What about 8? Right, 8 is a factor which is bigger than 7. So 8 into 9, I should actually say 9 into 8 maybe. So 9 into 8, right? So where 8 corresponds to this guy and 9 corresponds to that guy. Fine. That's one of the possibilities. Then you could have something which is bigger than that, so like 9 into 8 over there once again, but in this case 8 corresponds to this guy and 9 corresponds to this guy. And then you could have something which is even bigger than that, so maybe, so what about this thing? So something which is smaller than 8 would be 7, which is not a multiple, sorry, not a factor. And then you could have 6 over there, right? So 6 looks like something which could be there. So 6 into 12, that could be a possibility. Or you could have 5 or 4. So 4 is a possibility over here. So 4 into, I think, 18, right? So 18 4 72, yes, that's correct. And then you got 3 over there maybe. So 3 into 3 into 8, that's supposed to be 24, right? And you could have 2. So 2 into 36. And then finally you could have also have 1 over there. So you can have 1. So 1 into 72, that will be nice. So in fact all of these pairs are going to give me solutions. So how many pairs are there? First of all, there are 1 2 3 4 5 6 7 pairs, I think. So you will have 7 solutions to this equation, right, in integers. So number of positive integral order pairs a b such that this happens is actually 7. So the last question is, if an is 16 4 and 1. Oh, be a geometric sequence, so fine. An is like the terms between the terms in that sequence, fine. So a1 is 16, a2 is 4, a3 is 1, and it keeps on going like that. This is a geometric sequence. Define Pn as the product of the first n terms, then the value of 1 by 4, the summation from n equals to 1 to infinity of the nth root of Pn is. Wow. Okay, so first of all we need to find what this thing is, nth root of Pn. First let's find what Pn is supposed to be. So suppose we have any general GP. So you have AR squared all the way till AR power n minus 1, right? These are going to be n terms. If I take their product, that's going to be a power n into, you got r power 0 over there maybe. So r power 0 plus 1 all the way till n minus 1, which will be a power n into r power the sum of first n minus 1 natural numbers, which is n minus 1 into n upon 2. Okay, cool. So that's our Pn in this case. And what will be the nth root of Pn in that? So that way can, fine. So nth root of Pn will be a into r power n minus 1 upon 2, which is like a into square root of r to the power of n minus 1, which does make me feel like we are just dealing with another GP where the ratio is square root of r. Fine. So this nth root of Pn, that is another GP with the same first term, uh, but the ratio is the square root of what it was before. So this sum will be like 1/4 summation from 1 to infinity of nth root of Pn. That is actually 1/4. So what's the first term? The first term is 16, right? So 1/4 of 16, and then upon 1 minus r, the ratio would be 1/2 in this case, because over here the ratio was 1/4. So over here the ratio will be square root of that thing, which is 1/2. So 1 minus 1/2. So that will be 1/4 of 16 upon 1/2, right? This is just 1/2 squared, so like this is 1/2 into 16, which is 8. That's nice. That's our answer. This sum is 8. Okay, so I hope you enjoyed the video, and I will see you in the next one.